Hello, welcome back. The title of this lesson is called Multiplying Terms with Exponents, and this is part 1. This is an incredibly important lesson because as our explorations in algebra with equations and expressions get more complicated, we're going to bump into exponents a lot. So this is a foundational lesson on how to handle that. Now, before we jump into x's and y's, let's just talk about numbers. Let's talk about the number 3 raised to the power of 2. What does this actually mean, right? 3 to the power of 2. It means 3 times 3. We all know this. We've learned what exponents are. And when we have an exponent here, we just take this 3, which is what we call the base, and we multiply it times itself. And there are 2 of these 3's here multiplied, and that's what 3 squared means. Now, what if I change the problem? So instead of 3 squared, I have 3 squared, and I multiply it by 3 to the power of 4. Right? What would this look like? Well, if we think about it, if we go over here and write the answer to something like this, the first part, 3 squared, is just 3 times 3, right? That's the first thing. But then this is multiplied by this thing, which is 3 to the power of 4. And this is written as 3 multiplied times 3 multiplied times 3 multiplied times 3. Now, the first things here, this is the 3 squared. And the last 4 of them, this is 3 to the 4th power, right? But notice what's going on. We're multiplying these terms here that have the exponents in there, and they have exactly the same base. The 3 is the base of both of these, so that's why it's a bunch of 3's multiplied times themselves. And in the first part, we have 2 of them multiplied, and then the last part, we have 4 of them multiplied like this, but all of them are multiplied together. So what would happen if we wanted to simplify something like this? We have 3 times 3, but then times 3 times 3 times 3 times 3. What would all of this stuff look like if we wanted to kind of simplify this, which is what it is when we multiply out? It's going to be 3 to the power of 1, 2, 3, 4, 5, 6. 3 to the power of 6. So what we're basically saying is 3 squared times 3 to the power of 4 is equal to 3 to the power of 6. But notice that this is the same thing as just taking the 2 exponents that we have in the beginning, 3 to the power of 2, and we add it to the other exponent, 3 to the power of 4. So the bottom line is there's a very important rule here that you're going to use basically for the rest of your life in math. And that is when you multiply 2 terms that have exponents together, then if the bases are the same, 3 is the same as 3 here. When they're the same, then all you do is you add the exponents together. And so we get 6 here because 2 plus 4 is 6. This works for anything, no matter what the base is. Here the base was 3. And so it was a bunch of 3's multiplied together. But I could easily change the problem and make it, let's say, 5 to the power of 4 times 5 to the power of 1. I'm claiming that because the bases are the same, this is going to be 5 to the power of 4 plus 1. Right, which is 5 to the power of 5. Now let's check and see if this is actually right. What we would have here, 5 to the power of 4 is 5 times 5 times 5 times 5. There's 4 of them there, but then we're multiplying times 5 to the power of 1, which is this guy here. So this right here, this is 5 to the power of 4, and we're multiplying it. 5 to the power of 1 is this guy right here. And what do we get? It's all multiplied together, so it's 5 to the power of 1, 2, 3, 4, 5. Which is exactly what we predicted before. So a lot of students memorize these rules. Oh, when you multiply exponents, terms with exponents, if the bases are the same, we add the exponents. But they don't often know why we do that. It just comes about because the definition of the exponent is all the stuff multiplied times itself. And this one, same thing. So if the bases are the same, like this, then we can simply add the exponents together. It only works when the bases are the same because of the way the multiplication works. Now let's change the problem to more of like an algebra sort of thing. And let's say we have not a base of 2 or 3, but a base of x to the power of 2 multiplied by x to the power of 3. Right? What does this actually mean? Well, in this case, the base is some unknown thing. But whatever the base is, we call it x, it's the same base. Because whatever x is, it's here squared, and it's also here squared. This is the same as we had the same bases of 3 here, and the same bases of 5 here. They had to match. Here, the bases match as well. So what this is going to look like if you blow it out, this one is going to be x times x. So this we called x squared. But we're multiplying this whole thing times x cubed, which is x times x times x. And so this one is x cubed. So what's going to happen when you multiply all this stuff together? What you're going to get, x squared times x cubed, you're going to get, you have 1, 2, 3, 4, 5 of them, x to the 5th power. And notice that this is the same thing since the bases are the same. You just have the same base raised to the 2 plus 3 power. So this is the same thing as x to the 2 plus 3 power. So basically, when the bases are the same, then we're allowed to, and they're multiplied together, then we're allowed to add these exponents together. This only works when you're multiplying things, because if you multiply x squared and you multiply that times x cubed, then you're stringing all these x's together, and so the exponent just becomes larger. All right? Looks very complex, but when you know what you're doing and you know why you're doing it, then it's not hard at all. Let's take a look at a slightly more complex problem. What about 2 times a to the 4th multiplied times a to the 3rd? Now, for the first few problems, I'm going to write all of the exponents out to show you what you're doing. But then after the first few problems, we're going to stop writing everything out and we're just going to use the rule. And the rule is we can add the exponents together if we're multiplying terms with exponents and the bases have to be the same. The bases must be the same. So what does this kind of thing look like? We have a number involved, but that number is just multiply times a to the 4th. So it's 2 times a times another a times another a times another a. This whole thing is 2 times a to the 4th power. That's what it means. But we're multiplying by 3 more a's. So multiply times a, and then another final times a. And this last thing is a to the 3rd. So what we're doing is we're multiplying this thing times this thing, but this is just 2 multiplied by 4 a's, and then this one is just 3 a's multiplied together. But both things are multiplied together in the end. So what we get when we do this is just the 2, it just sits there because there's an invisible 1 like in front of every term with a variable, there's an invisible 1. You multiply the numbers as usual, but there's just a 1 there. So it's just a 2. And then the a, how many do we have? 1, 2, 3, 4, 5, 6, 7. And so it's 2a to the 7th power. But notice what we've done is we just take the numbers and multiply all numbers together, but there are no other numbers here other than the invisible 1. So the 2 goes into the answer. And then the bases of the exponents are the same. So the a comes down, same base. And then we just add these exponents together to make a 7. And so this writing everything out business, we're going to drop that in a second, but that's what's actually happening. That's why we're able to add these exponents together. All right, let's take a look at another one. Let's take a look at 3 times b multiplied by b squared. Let's see if we can write the answer and then do the expanded form. Well, we're basically saying that when we multiply terms like this, we multiply all numbers together, because when we blow it all out, the numbers are going to be written in there, but there are no other numbers, so the 3 just goes into the answer. But then we have b times b squared, same base. So the b goes into the answer and we add exponents, but there's no exponent here. You might say there's nothing there, but really there's an invisible 1 here, because b by itself is b to the 1st power. So this is really a 1 plus 2, which is a b to the 3rd power. So that is the final answer, but let's just write it out just to see what it looks like. This term, the 3b, is just 3 times b. This term is just b times b, because b squared is b times b, but both of them are multiplied together. So what do you have? 3 here, and then b times b times b, that's b cubed. This is the definition of the exponent there. So we're going to write them out to kind of like give you practice, but all you need to do is multiply the numbers together, and then if you have the same bases, then you just add those exponents together and combine them. And this is called simplifying expressions that involve exponents, because this is not as simple as this. This here is not as simple as this. So just like we learned to simplify fractions, just like we learned how to simplify, other things in math, we're going to be simplifying these terms that involve exponents. All right, let's do the same kind of thing again. Let's take a look at 2 times y to the 2nd power multiplied by 4 times y to the 5th power. Now, before blowing it all out, let's see if we can figure out what the answer will probably be. We have 2 terms multiplied together. We always just multiply numbers together. This is 2 times 4, positive 2 times positive 4, which is 8. But then we have also these exponents multiplied together, or these terms with exponents. It has the same base. So the base will go into our answer, and we can add the exponents, which is 2 plus 5, if you want to write it like that. Then it'll be 8y to the 7th power, and that's it. And there's not much work to show other than to know that you multiply the numbers, and then if the bases are the same, you just add the exponents. Now, again, we'll do it just for a few more problems. What does this look like? This is 2 times y squared, which is y times y, right? And this one is 4 multiplied by 5 of these y's. 1, and there's number 2, and there's number 3, and there's number 4, and there's, if I can write a y correctly, number 5. But this term is multiplied by this term, so there's a dot between them. So because you have the numbers, this is 2 times y times 4 times y, and so on. Notice that when you multiply a long string of things, the order of the multiplication doesn't matter. You know, 2 times 3 times 1 is the same times 1 times 2 times 3. Any things that you multiply together, you can always rearrange the order and you always get the same answer. That's called the associative property of multiplication. We talked about that a long time ago, right? So because we can rearrange the order of multiplications, we could write it like 2 times 4, moving the 4 over there, and then these 2 y's right here, and then all of these. And then we have another one, and another one, and another one, and another one, and another one. And so then we multiply the numbers together to get 8, and then we have 1, 2, 3, 4, 5, 6, 7 of these y's there. So again, we're not going to write it out every time, but I need you to know what you're doing. The reason you're multiplying the numbers is because everything gets multiplied anyway, and then of course you can multiply the numbers. When the bases are the same, all of them can be written together and make a new exponent where the exponent is just the addition of the 2 exponents you had in the original problem. But the bases, the thing you're raising to the power, must be the same in order to combine them like this. Now let's take a look at something a little more complex. What about negative 3x multiplied by 5x squared? Now, this one's different because there's a negative 3 in front. What do you think you're going to do? I've been telling you that when you have these things multiplied together, just multiply the numbers. So 5 times negative 3 is negative 15, right? Because negative times positive is negative. And then we have these x's multiplied together, same base. Here's an exponent of 2. Here's an exponent of invisible 1. 1 plus 2 is 3, so we write this as x to the 3rd power. So it's negative 15 x to the 3rd power. Now, just for clarity, this is negative 3 times x, and this one is 5 times x because it's x squared, but they're all multiplied together. So if I wanted to, I could rearrange the 5 and the negative 3 together. That would multiply to give me the negative 15, and all the x's would sit next to each other, which would give me x to the 3rd power. All right, I think we'll just do maybe 1 or 2 more problems with kind of like blowing it out, and then after that, we'll just continue on. Let's take a look at negative 2a cubed. And then we're going to multiply that by negative 4a cubed. Now, I chose to wrap this in parentheses. This looks clear because whatever this is, it's multiplied by whatever this is. Now, let me show you what happens if you remove the parentheses. And instead of putting parentheses, you just put a little dot right there because that means they're multiplied as well. It means the same thing. This negative term is multiplied by this one, but it's easy to miss the dot, so it looks like subtraction. It looks like this is subtraction at a glance. So it's better when you have negative terms to wrap it in parentheses, and if you want to, you could wrap this in parentheses. You don't have to, but you could. And this is very clearly that this term is multiplied times this term. So what do you think we will get? Well, we say we just multiply numbers, right? This is a negative 2 times a negative 4. Negative times negative is positive, and 4 times 2 is 8. Here we have the same base for these exponents, and the exponent of both is 3. 3 plus 3 is 6, so it's a positive 8a to the 6th power. Now let's blow this one out and see if we agree. This one is negative 2 times a times a times a, because that's a cubed, right? And this one is negative 4 times a times a times another a. And they're multiplied together. So to make sure we understand, with the same problem here, I don't want to put a dot here. So I'm going to kind of like wrap parentheses around there so it's clear that we're multiplying them together. So I could rearrange the numbers together. It's going to give me a positive 8, and then all the a's will be together, and there are 6 of them. So I think at this point, maybe we'll do one more where we kind of blow everything out underneath it, but after that, we're going to stop doing it. Let's take a look at 5 times y multiplied times 2 multiplied by negative 3y to the 4th. You see how this can kind of look like subtraction? So instead of writing it like that, I'm going to put this last term in parentheses, and this means all of these are multiplied together. There's an invisible multiplication here. Now, what do you think is going to happen? Well, we multiply all numbers together, right? 5 times 2 is 10, and then this 10 times negative 3 is going to be negative 30 because 10 times 3 is 30, and this will be a positive. 10 times a negative gives me a negative. Now I have y here, and then y to the 4th, same base. So I can write this as y to the 5th because it's 4 plus 1. There's an invisible exponent of 1 right here. So the answer is negative 30 y to the 5th. So let's blow this out. What is this right here? This is just 5 times y. What is this right here? It's just the number 2. And what is this right here? This is negative 3 times y to the 4th, which is 1y, there's number 2, there's number 3, there's number 4. So this is all multiplied together. I'll make my dots real big. And you can rearrange the numbers. You can, when you multiply things, the numbers can go in any order you want. So I can write this as 5 times 2 times, I could put that negative 3 in parentheses to make it clear, and then times this y, and then 4 more of them. Right here, we'll have 1, 2, 3, 4. These are these 4. This one comes from here, and then all the numbers are together. What do you have? 5 times 2 is 10, times negative 3 is negative 30, and then all 5 of the y's are there as well. So from this point forward, I'm not going to kind of write everything out. We need to learn to look at the expressions and know what to do. And I've done enough of them where you should be convinced of what you're doing. Certainly you can write these out if you need to write them out, absolutely. But for the rest of this lesson, we're not going to do that. Let's take a look at 3 times b squared times negative 2 times b to the 4th power times negative 2 times b to the 3rd. Now, this can get a little complex when we have so many things going on. So let's just focus on multiplying and kind of like simplifying the first 2 terms just by themselves, right? What would happen if we just multiply these first 2 terms? Forget about this one. We'll do that later. Well, 3 times negative 2, we multiply the numbers, we get negative 6, right? And then these get multiplied, same base, and we add 2 plus 4, which is 6, so it's b to the 6th power. So these multiplied together give us this, and now we finally need to multiply by this negative 2b to the 3rd power. All right, but here we have a negative 6 times a negative 2. That's a positive number, positive 12. We have the same base multiplied, but we add the exponent. 6 plus 3 is 9, 6b to the 9. And so the answer is 12b to the 9th power. Now, you don't have to do it in 2 steps. If you want, in your mind, you could say, well, 3 times this is going to give me negative 6, and then negative 6 times negative 2 is positive 12. And then you say this b and this b and this b, it's going to be a b in the answer. 2 plus 4 is 6, and then 6 plus 3 is 9. So you can do it all in one step, but sometimes it is a little bit better for us to break it up. All right, only 2 more problems. What about x squared multiplied by 7x to the 3rd power multiplied by 2x? All right, so same sort of thing. Let's try to do this one all in one step because it's not so bad really. There's an invisible 1 in front of this as a coefficient, times 7 is just 7, and 7 times 2 is 14. So we multiply our numbers together, and then we have exponents with the same base here. So we add them. 2 plus 3 is 5, and then 5 plus 1 more here. There's an invisible x to the 1st. 1 more is 6. So it's 14x to the 6th power. 14x to the 6th power. That's the answer. Now, if you want to do it in little separate steps, first let's multiply just these. So what are we going to get? The 7 times invisible 1 is 7, and then we have x to the, we add these, 5th power. So that's what happens when we multiply this, but we still have to multiply by 2x. And then we multiply the numbers. 7 times 2 is 14, and we have the same base, so 5 plus invisible 1 is 6th power. Get the same thing. So whether or not you kind of break up your steps or not, you're going to get the correct answer either way. All right, I think I'm going to solve the very last problem on this board right over here. I think we have plenty of room. Let's take a look at negative 4a cubed multiplied by negative 2a squared multiplied by negative 6a to the 5th power. Now, I actually do think that it is a little bit easier to do this in steps because you have so many negative numbers. You don't want to do too many things at once. So let's just focus on multiplying these first 2 terms together. What do we get? Negative 4 times negative 2. 4 times 2 is 8. Negative times negative is positive, so it's positive 8. but we have these exponents. We have the same base, so the exponent is going to also, the base will be the same, but 3 plus 2 is 5. So this whole thing works out to 8a to the 5th, and we still need to multiply by negative 6a to the 5th power. We multiply numbers. 8 times 6 is 48, but positive times negative means it's negative 48. And we have these same bases here, so we add the exponents. 5 plus 5 is 10, so it's a to the 10th power. So it's negative 48a to the 10th power. So I want you to really look at what you've accomplished during this lesson. We started out talking about very simple things with exponents. 3 squared, 3 squared times 3 to the 4th, and how to simplify them just with numbers and getting you comfortable. And then we moved into very simple problems with just a couple of little exponents running around, and we finally ended the day with what anybody would consider to be pretty tough looking. But then hopefully by the end of it, you can see that even tough looking problems like that really aren't. You just have to know how to tackle it and how to get confidence in what you're doing. So when you first learn this stuff, you don't know, nobody knows to add exponents and if the bases are the same or they're not, nobody knows that stuff. You only get it through practice. So go through this lesson again, write all these problems down and solve them yourself. When you're getting down to the end and you're getting the right answers and you know what to do and you feel comfortable, then follow me on to part 2. We'll make them even more complex to give you more practice with multiplying terms that contain exponents.